Our technician Ben will demonstrate the sterile technique for passing cells. All of the steps will be carried out in the sterile cabinet. Its sterile environment is maintained by continuous airflow. The cabinet will turn on automatically and air will begin to flow once you open the door. Only open the door halfway. Opening the door all the way will generate airflow disturbances and introduce contaminants into the cabinet. Before you start your work, you will need to put on gloves and spray them with 70% ethanol. Using 70% ethanol, clean the work surface inside the cabinet by wiping inside and working your way out. You will also need to bring all of the necessary materials such as pipettes and solutions inside the cabinet prior to initiating your work. This will help minimize airflow disturbances when working with the cells. Once everything is inside, retrieve a flask of cells from the incubator. Note that the flask has a canted neck. When the neck is pointed up as shown here, the cells are attached to the bottom surface and submerged in growth media. It is important to keep the cells submerged in growth media to avoid drying. Place the flask in the middle of the cabinet with the growing surface down. All sterile work should be done in the center of the cabinet. Remove the lid from the flask and place it on its side. This will minimize the chances of contamination. We will now trypsinize the cells. Remove the media from the flask using a sterile 5 milliliter pipette. It is best to tilt the flask sideways to avoid touching the cell growing surface. Put the flask down with its neck pointed up. Discard the spent media in the liquid waste jar and the pipette in the waste bag. Loosen the cap from the trypsin and PBS tubes. Open a new sterile 10 milliliter pipette and transfer 10 milliliters of PBS into the flask, avoiding the cell growing surface. Turn the flask with neck pointed up and rock the flask to distribute the PBS solution evenly. This step will rinse out any remaining growth media solution that could inhibit the action of trypsin. Using the same pipette, discard the PBS solution into liquid waste jar. Using a new sterile 5 milliliter pipette, transfer 2 milliliters of the trypsin EDTA solution into the flask. Again, rock the flask to ensure that even distribution of the trypsin across the growth surface. Replace the lid on the flask and return the flask to the incubator for 5 minutes. Make sure your flask is labeled with your group number. The trypsin EDTA solution will cause cells to detach from the surface of the flask. After 5 minutes, the cells should be rounded up, detached from the growth surface, and be floating freely in the solution. Make sure that this is the case by simple visual observation using one of the phase microscopes located at the end of each bench. If the cells are still attached, return them to the incubator for a few more minutes. When the cells are ready, return the flask to the sterile cabinet. Loosen the cap on the new and old flask and on the media tube. Using a new 5 ml pipette, transfer 4 ml of media into the new flask. Using the same pipette, transfer 4 ml of media into the new flask of cells. Use the pipette to resuspend the cells. Transfer 1 milliliter of the cell mixture out of the 6 milliliters into the growing surface of the new flask. Place a lid on the new flask and keeping neck up, then rock to distribute the cells evenly along the growth surface. Return the flask to the incubator. Remove all material from the cabinet. Any remaining cell solution in the flask should be transferred to the liquid waste jar. The old flask should be thrown into the biohazard waste bag. Pour out any remaining solution from the tubes into the sink and discard anything else into the regular trash can. Wipe down the cabinet with ethanol.